As a recap, our project aims to predict the sales data of Walmart items based on information provided, such as the location of the stores, category of items, price, and date. Due to the large number of data we have, we decided to focus on the stores in California only. And considering the large number of zeros in the data, we ended up aggregating the daily sales to weekly basis. We first did some descriptive analysis of our data to see how it is distributed. There are three large categories of items in total, including foods, households, and hobbies. Here, the two graphs show the average unit sales per week by different category of items. And from the box plot, we can clearly see that the food item sales are on average more than 2 times higher than the other two categories. Similarly, we also looked at total sales of each category. From the pie chart, we can see that as what we expected, food items make up more than half of the total sales. And hobbies items are the least, about 10% of the total sale. Especially for the food items, we can see a pretty clear seasonal pattern over the course of 5 years. Looking at the red line on the line chart, and there's some kind of pattern for the household items, but for hobbies, there isn't much fluctuations. Next, Lucy is going to talk about data merging and modeling.
Okay, thank you. As Lisa mentioned, that we are only focusing on the California stores. Here, we're making an assumption that different stores in different states actually having similar patterns. After the aggregation, the primary key for each instance are week ID, item ID, and store ID. We end up having the total number of instances as 2 million. And the final features we included in our modeling process are the IDs, as in item ID, department ID, category ID, and store ID, the sale price, and time information, including week number, week ID, month, and year. As for the special events, we included SNAP CA, which is a government low-income food support program, and the cultural, national, religious, and sporting events. So far, we have finished running 3 models. We are doing a 80-20 split between the training and testing set, and within the training data set, we did an 80-20 split to have a validation set. And as for the baseline here, we are using the average unit sales for the training data set to predict all the instances. And we can see here that the training RMSE is 31, validation as 23, and testing as 22. We tried to use the linear regression comparing between regular, ridge, and lasso, and of having the best performance for lasso linear regression. The training time is really short. It has a better performance than the baseline, but not much, giving us the first insight as the linear models probably don't work well with the time series we're having in the data set. Therefore, we turn into the LightGBM, which is a tree-based model. It's running slower, but giving us a better performance, 17 for training, validation as 16, and testing for 17. And as for further improvements, we are thinking of including the XGBoost into our model. And since although these models are giving us better performance, it's not outperforming much. We think that more feature engineering would be necessary. We are deciding to adding in more lag variables ranging from lag half a year until lagging a year. And as for one of the insights, we think that as for training RMSE, which is higher than the validation and testing, there might be something to do with the overfitting and the number of instances in the training data set.